We're talking about MLOps in 2022. So what's changing out there? What's happening? And again, we're going to look at kind of working with a single approach versus multiple approaches that we have. Sometimes when it comes to clustered environments. Came off just a session on big data and optimization a few minutes ago. So welcome again if you were in that session, and in this session, great to have you around. Today, we are really seeing an increase in the usage of two techniques: AI, artificial intelligence, which is kind of where we allow the artificial intelligence to go off and find information for us. The other approach is, of course, machine learning. And in machine learning, we often know the data sets that we're dealing with. And from there, we try to build out our algorithms for those data sets, those known data types that we're dealing with. So this seminar, we're going to fill in a few little bit of details around that and then move right into MLOps, why we need it, and of course, the life cycle, which is important to understand. So really, it's using computer algorithms to understand data. We typically work with some kind of sample data. We will train that sample data. So we take a slice of that, so maybe 20% of the data to work through our training. We then take another slice, we're testing. Once we're assured that the model that we are creating to look inside of the data and produce some kind of, it could be a visualization or it could be other information that we're trying to present, that prediction is correct, right? That's really what we're looking for here with the software. And there's many tools out there. We'll take a look at a few of them shortly. The machine learning model today has become something like a commodity. We actually see marketplaces today where you can buy these models, these algorithms ahead of time, or within the organization they become a commodity because others want to use your model, that thing that you trained and spent the time preparing and getting right. The idea behind the model itself is simply to give us insight to something within the organization. There's an example here, of course, with regards to the business objective. So an insurance company might want to have a recommender tool that enables them to recommend other products to others, customers in this case, based on what they've bought previously. So it might recommend, if you have two cars, house insurance, or if you have two cars and a house, maybe boat or motorcycle insurance, or like my chief developer, airplane insurance. Whatever the case may be, it's going to give you some information, but it has to be modeled on something in the real world, and that's the important part. And that's why in ML, we have to have an understanding of the data itself, whereas in AI, it tries to glean information for whatever it is that we are interested in. When we work with machine learning today, one of the key parts of that is that sharing. Over time, models change, so we want to update them. But at the same time, we want to be able to share them with the organization. And that leads us to something called the machine learning lifecycle. And that's part of MLOps. You could compare it to DevOps used for developers, or even data ops used by data engineers to ensure that their raw data and the data lifecycle is never lost. In the case of MLOps, really what we're talking about is checking these machine learning models into some kind of repository. That repository then gives us the ability to have it accessed by many people, but also to be able to update that model over time. And you can see here, you build the model, you deploy the model, you iterate the model, you define, again, maybe a new business goal, or that's where you're starting. And through that, you kind of, get the data prepared and go back through building, the machine learning model. But really, the understanding of the data set here is critically important for being able to work with this and scale out your applications, whether it's a single application running on something like your local machine. We often talk about, PySpark running in maybe Anaconda, and you're using a Jupyter notebook to create your machine learning model. Maybe you start with something like scikit-learn or some other location that really lets you glean information as a starting point for that. But eventually you'll check that in. So create the model to predict the outcomes from the data. Again, single process, probably installed, something like Anaconda or R. Anaconda's, A-N-A-C-O-N, right, is Python based, and it uses Jupyter notebooks for its environment. That might be your starting point. Or you might decide to use R. Maybe you're going to use R Studio, which is quite a common product, right? But you're most likely doing this on your local machine initially. At that point, you run through the model, you ensure that, again, reliable, fast, accurate, all of those things. And there's the last part, that it can be used by others. This is the part that often breaks down. We have a bunch of wizards building machine learning applications, but they're not sharing their knowledge. And the important part of MLOps is the ability to share that knowledge with others. So that's going to allow us to have ways of ensuring that the inputs and the predictions that the model is making gives us feedback so that we understand that it's working properly. Over time, the model's going to evolve, as we said, and at that point, we have to apply additional things. So monitoring, updating, over time, as we said, it really becomes critical here in the overall operation. And it is often a step that's overlooked by organizations themselves because they don't plan for this. So today, the machine learning lifecycle has become critical, not only for the performance of the systems, but moving forward as data is being updated or changed, and the model will have to be updated and changed as well. So this is just a set of processes, right? Like everything else, we're defining a set of processes that looks at what the business need is and allows us to use our machine learning code in the production environment. But the key is deploy that same code from that on-prem single instance to perhaps the on-prem distributed environment where we're running Spark or some other tools as the underlying environment that we run our ML code in. We could also look at and think about this from the perspective of then moving to a distributed environment, maybe in the cloud. And I'm not saying one is better than the other. I'm just saying that organizations tend to have kind of a rollout of this over time, often starting in on-prem, often moving to the cloud because of the costs involved, right? When we move to the cloud, I've used this term a lot today for some reason, but we get no-ops or serverless applications whereby the infrastructure or the platform is maintained by the cloud provider. We only spin it up and we only use it in a pay-as-you-go environment in this case for that short window of time that is required, saving costs and so on. Supply chain right now, it's pretty incredible how long it's taking to get equipment. We're actually talking about October now for some of the blade servers that we need in my organization. So MLOps means developing an approach to the monitoring, scalability, and evaluation of your models. Remember, not all models are going to work. They may not work properly for this particular data site, but we've developed that model, and maybe somebody else looks at what you've done and is able to use that and derive some of the information that you created for yet another set of models that are successful. So it's always about training the model, reproducing, and deployment, right? And today we want to do that in an automated way. So if we can check in those models into a repository, think Git, GitLab, GitHub, Bitbucket, or some other repository from a cloud provider, then we have a way of essentially making them available. And then when somebody needs to work with it, it's simply a matter of going and bringing that model forward to their organization. Today in the cloud, we have lots of tools for doing so. This is just an example of SageMaker. SageMaker, of course, allows us to create our notebooks. Our notebook is where we're going to run our ML code. However, we don't necessarily need to do that every time, because if we've trained the model, then the algorithms will be available to us from here, or we could buy algorithms today. It's quite common as a commodity to buy those. We also could do our own hyper tuning, meaning that we can provide the parameters that are specific to that application. So we make a new generic model that allows for those parameters to be passed, much like we do with functions, to tune that model in real time. So tools like this are certainly giving us that capability. If we went over and looked at the machine learning environment here in Azure, we could create a workspace for our environment. Inside of that workspace, you'll notice some of the things that are set here, like resource groups. You'll notice the workspace name, where we're going to run it. Again, this is going to run in different regions around the world, depending on where we want and have the data. Remember that there are regulatory requirements around that we want to be cautious about. We don't want to be fined like Google and Amazon for moving data out of the European Union into North America to the tune of about $200 million. We have, of course, it's a storage account where we're going to store the algorithms that we write. We can have a key vault so that only our organization is able to access that. All kinds of things like this set up. And you'll notice down here at the bottom, container registry. So we can actually have a container registry for registering our MLOps. In the case of Google, very, very simple, similar. Instead of using resource groups, in Google, we tend to use projects. So the project then would have assignment of individuals and the resources that are associated with it, similar to the resource groups in Azure. And we could start working with maybe a BigQuery, which would allow us to work with large data sets. Again, provisioning things with our knowledge of SQL or writing code around that, maybe in Python or Java or Go, if we need to. In the case of streaming data, we could do that in real time and break the data up, maybe taking windowing through our algorithms and providing it that way. Or even here with Dataproc, which is the Hadoop-based machine learning approach. Google also has some preset pipelines that you can take advantage of. So you'll see that there's pipelines in here in genomes and other pipelines. And same thing here in healthcare. There's actually a marketplace around healthcare products. But essentially, you create a project and then you set up your application to run in that environment as far as machine learning is concerned. So those are just some examples of the more online aspects that we see today, so that we can take advantage of again that successful model. Remember, the successful model is going to allow us to either reposition or repurpose them, which gives added value to the organization. Of course, saves our people time as they go out to deploy those applications. In this case, the machine learning aspects. Here's a visualization of machine learning ops, and you'll notice that we've got the word dev in there. As I said, it does flow very similar to what we would do in the DevOps environment if we were programmers or developers. We would check our code in, maybe using something like Jenkins or some other package. We could do that with ML as well today. There's lots of tools around that, which I'll talk about momentarily. We've got the data and the model being built. Maybe, again, that's done on-prem, maybe on a laptop or desktop, and then deployed on-prem to a distributed environment where the data exists, or maybe it's going to the cloud. Whatever it is, we're going to, of course, make sure that it works first and then package it so that we can release it and monitor it at the full-scale production environment level that we need to run these at in order to do, high-scale calculations and return information. This is a really good slide on that process that gets undertaken. Not really going to go through all of the touch points here, but just to say that there is generally a business use case, and there's data that is derived for that business use case. That data may be a combination of perhaps SQL and also a data lake, maybe like Snowflake today, which is a quite common product out there. We're not forgetting, RDB, RDBMS, NoSQL combinations here. That's pretty common when it comes to that. We then decide to figure out the features. That's part of the data engineering side of things, where the data engineer will prepare the data for us. They may do some model training in order to validate some of the data that they've worked with. Again, that's up to that process. However, we often see at this layer a combination of data engineering and data scientists. We are still shy, almost 50,000 individuals, about 20,000 as data engineers, and about 31,000 as of this month for data science jobs across the United States alone. In Canada, it's around 25,000 in total jobs that are available in these areas right now. The idea, though, is with MLOps, we start to save information, right? We start to save information. And this is really where MLOps comes in. As all of the other stuff is going on, we are ensuring that that data gets saved. The whole idea here is the process, but the important part is the saving and reuse of those models within the organization. Right. So again, I'll provide these slides. If you haven't downloaded them already, I will provide my slides at the end with my marked up notes. We know that process involves some kind of exploratory data analysis, typically done by the data scientists today, sometimes done by data analysts, just because we don't have enough data scientists, sometimes, as I said, done by data engineers. But this generally involves operations at scale to clean the data, provide some kind of hypothesis or hypotheses that we make about the features and pulling out those features, right? We're always looking at how can we do this better, whether it's using big data systems like Hadoop and Spark or others. There's lots of other choices there, or whether it's looking at our relational database management systems, where we've got our, perhaps our data warehouse as part of that solution. Often today we see things like data marts, which are the combination of the real-time transactional data, the OLTP, and our OLAP data coming from our data warehouse and getting insight into that. I've done a couple of major projects with the IRS, in particular down in the US, for that reason, right? Here in CRA as well in Canada. So the processes really take you through model development. We mentioned training and testing. Depending on what you're using, you may end up working with algorithms that already exist, as I said earlier, or you may create your own algorithm. Again, depending on what you're doing, you probably want to give it a name that somebody can find. You want to make sure that the image itself, if it's something that we want to back up, is going to be backed up, probably in a container or some other location. We want to, of course, set the type of service that we want to use. Interestingly enough, right now Amazon offers a 768 CPU 12 terabyte of memory device. So if you want to go crazy and spend a lot of money, and it's not that expensive, it's about $100 an hour, but you can access that on a pay-as-you-go basis, right? You don't have to go and try to purchase that. That's a a machine that's going to set you back somewhere in the half $1,000,000. If your organization can't afford that, then you could certainly take advantage of paying for a slice of it. Again, the type of model that we want to do, this one's in the training side of things. So we would use training, and we can do one of two methods. We can use streaming, so pipe mode, or we can use file mode here, depending on where the data set is coming from to our operations. Assuming that it's already maybe in a bucket, or it's already within some kind of data source here that we would use, then it's fairly easy to start going through those steps, tuning the specification and then moving forward. Again, I'm just showing SageMaker's way of doing that. Once you've got the job done though, right, like something like this, a k-means job, then what you would do is start to work with this job. And again, that k-means job could be used over and over again if this is something that I need to do for clustering purposes. I may be able to use that clustering purpose over and over again. Well, if that's the case, I can come up here and clone what already exists. So I'm not necessarily working with what was done only here. I can go and clone it and then make changes to it. So I might change the type of algorithm I'm using. I might change the type of service, instance type. I might change other hyperparameters, as we mentioned earlier, within the application of that machine learning piece. But you can see here, all of these things allow me to go in and modify essentially the job that I already had in place. And that's really what we're talking about here. We now have something that was successful. We're modifying it because maybe a change in the data set, or we're modifying it because we have a different data set that we want to use it against. But we don't have to start over. We can essentially build off of something that already exists in the environment that we've been working in. And that's the critical step. Through this process, right, we can now scale that out and deploy the information. Of course, packaging the code, maybe if we're doing this with Python, we're using a Python pickle or a zip file for that. Quite common to do that. We upload that maybe into S3, or maybe we use a Lambda function in the case of AWS, or some other kind of function from Azure or Google. And we probably have it in a Parquet format, which allows us to have that encoded encryption for the data itself. Remember, we are going to use it in one of three ways. So on demand, or we're going to do it in a batch, or we're going to embed the model inside of an edge or mobile device. I had a conversation yesterday about this. Look, it depends on the type of device, right? You're going to need a very sophisticated ARM processor in the lines of what Apple has done today with their iPhone, what is it, 13 or 14, and with their Mac Mini choices. So those kinds of controllers, in this case, would be okay for working on. But you definitely need to have something that with some robust CPU in it. I believe the new MacBook Pro has up to 12 CPU available. I think that's what Gwyneth bought the other day. So quite amount of CPU available anyway. Scaling, right? We said start with a single notebook or some other integrated development environment. Look to do vertical or horizontal scaling depending on what makes sense. Horizontal scaling is typically distributed environment, so a cluster, whereas vertical scaling, again, we're talking about adding more memory or CPU. Add CPU, memory, faster drives too, typically. So little bit of a difference there in the approach. One, we're looking at a distributed system where the data gets distributed, so probably looking at partitioning and sharding. The other, the data is being brought in probably from a network source somewhere, NFS or S3 or something like that, and we're throwing more CPU and memory at it to get that data into a data frame in memory so that we can then run our machine learning algorithms against it. GPUs, of course, everybody's taking advantage of that today, whether it's in video or somebody else, but you definitely need to make sure that it has that capability. We already talked about containers. So putting our application in a container and then using something like Kubernetes to orchestrate the scaling up or scaling down of that application. So again, this would be a good thing for scaling. And then we mentioned about serverless or no ops. Again, this is allowing us to use platform as a service or software as a service, where we don't have to maintain the underlying machines themselves, which can be very, very tricky to do. And again, if I'm a data scientist, I don't want to be playing around with the operating system underneath. That takes away from the time that I actually work against the data set. And in fact, recent studies have shown that data scientists spend between 40 and 50% of their time doing things like that. We're getting the environment set up, preparing things for their actual operation, and they only spend maybe about 30% of their time actually doing something with the data. This is detrimental to obviously successful operations, and we need to find better ways of doing that. I'm going to share with you something that's really cool. A gentleman by the name of Kelvin has put together what I think is a really good piece of information for you. This is called Awesome MLOps, and it's kind of a resource of all of the things that you would need to think about building out your applications. Things like AutoML today. This is just automating the machine learning, as we said earlier. CI/CD processing. So again, checking that ML in to some kind of repository, could be online, could be on-prem, it doesn't really matter. And then other mechanisms here. So do take a look at this. There's a great breakdown of the different tools around these areas. So if you're looking for specific tools in AutoML, if you're looking for specific tools around cron jobs or data cataloging, you can see data management here. Delta Lake, of course, is the one from Databricks. There's a few others here that are mentioned. So this is by far one of the best sites I've seen recently that's collecting information for you. It allows you to, of course, go in and find that information based on, again, the information that he's sharing, but also shares books and articles here as well for you. A lot of you know that my other favorite site is Towards Data Science. So for those of you that perhaps have not gone to this site before, I would highly recommend Towards Data Science. It's a collection of articles around these subjects, including machine learning and AI. So do take a look. You can search for your particular topic here that you might be interested in. So I hope that those two resources are useful to you as you continue through and you look at some of these ideas behind processing and scaling of the actual MLOps. We rely on lots of data when it comes to MLOps, and this is one of the problems that we get into quite commonly. Is it's hard for us to track that data within the organization. This morning, I was talking about two areas that are used for this today. In the other lecture, data governance and MDM, master data management. Those two areas are very, very important today for tracking data within the organization, and they still need to be applied, whether it is me working on my own laptop or my own desktop running algorithms, or if I'm moving to some environment like the cloud. In fact, it's even critical in the cloud, especially for organizations that are doing cloud data first or cloud first data operations, because they tend to get all kinds of duplicate data and disparate data sets very quickly. It becomes kind of the wild, wild west. So applying some kind of master data management along with data governance is very, very critical to these organizations. I've dealt with some insurance and financial industry applications around this, and without that, I will certainly tell you that it gets very overwhelming for the individuals in the organization, typically the data engineers, because they're told to this is the BI folks or the BA folks saying this is what we need, and they start trying to find the data and it's all over the place. That again takes away from the time that they have to prepare other data sets and so on, and that just leads to a whole bunch of mess within an organization of factors that create instead of making it easier, it certainly makes it harder for the organization to move ahead. Again, track parameters. We just mentioned about hyperparameters. Those are the ones that are used. You'll notice in the clone job, when I brought that up, it immediately showed me the hyperparameters that were already being used here. But it also allows me to then go in and set additional hyperparameters that I may want to use within my application. So this is a kind of a nice tool for tracking that in itself. And since we're checking that in to our repository, in this case, saving the model will do that, then we have that capability of going back and tweaking those things quicker. So again, tweaking an important part of this. Of course, small changes, as we know, can lead to enormous differences. Small changes in the data over time in particular can cause the data to become unstable or unusable. So we want to make sure that we're always working with good data. And of course, tracking the model features is important. This will, of course, lead to better accuracy. So again, that's why we need something like MLOps here in this environment to make it successful. When it comes to that, we break it down into different areas. So monitoring the deployed software or app, absolutely important. If we can use tools, as we saw a moment ago, like SageMaker, where we are, tracking our training jobs in a tool, it's going to be a lot easier to do that. Again, this is not the only way to do it. If we're using some kind of CI/CD process like Git or CML or something like that, that really does give us a great starting point for keeping track of the deployed software overall in the applications that we're using. Debugging, of course, gets very, very complex because there's a number of different touch points. We just saw the hyper parameters, but there's other things that change over time. Having access to that, of course, is important. Updating the model, we mentioned earlier, and mentioned a few times as well. And then versioning. And I think this is something that a lot of people don't realize, that versioning of the model, we need to keep those versions. Remember, there's a data lifecycle. And within the data lifecycle, we may need to go back in time because somebody has done something wrong to the data. Maybe some kind of reconciliation was done, or some kind of cleansing was done, and that affected the data model. We may have to go back to the original raw data source, or we may have to go back to an incremental part of that data source. It's important that we have versioning of that. I work with a client in Boise, Idaho, that builds Lexar USB chips called Micron. Versioning is critical for them because it allows them to know as there's being changes made to the chipsets that are used in the USB keys or the chipsets used on crucial memory and other things, they can track that. And in fact, what happens is each set of those USBs that are produced, each set of memory that's produced is actually tested before it's sent on. And the versioning could identify very quickly patterns that are leading to errors in the building of the chipsets and of course the deployment of the chipsets robotically onto the wafers. So these are things that we utilize effectively. In fact, for another organization, we actually own patents on doing that, looking at the errors and warnings and then preventing the designers from actually developing a chipset that has errors that were previously identified because they chose maybe the wrong voltage or something else in their design. This is the overall pretty picture of really what is done in production. So we've got that configuration on the far end. We've got the data collection, the data verification. This goes back to that process model that we saw earlier. And you can see then down here, after all of this is done, we've got our feature extraction. We've got the monitoring that are going on. So again, these are things that we probably want to keep track of in some way. So what features were used for this model? Now I'm going to take that and clone that, and I'm maybe going to tweak the features that I want to work with. Remember, features are facts or dimensions often that we're dealing with. So often presented as columns with their particular data types. There's other types of features that we may look at as well. But from the monitoring perspective, we have that capability here. And then we break this down into the actual stages. So the scoping stage, when we're told what we need to do, right? Somebody says from the BI or BA world, oh, we need insights into this data for this reason, for X, right? And that's normally our goal, right? Is our starting point of whatever the business need is. We then do the data engineering piece, as we said. So moving the data, getting it prepared. More and more, this is blurred lines today where we have the data engineer, the data scientist, and the data analyst going down and doing the data engineering, the prep of the data, the movement of the data, the ETL component. That's simply because we don't have enough people in the organization right now to do this. And it's critical today. There are major gaps in this area and major gaps in understanding. And we certainly need to retrain and uptrain or upskill folks to be able to meet those needs. We've got the modeling side of things. Not saying that you have to go and get a master's degree here in this, but certainly when you start to work with modeling, having a clear understanding of these ideas behind this, whether it's trigonometry and calculus, all of those things, statistics, you should have a good understanding of it, or you should at least be able to go out and train yourself on it. I often talk about doing this on your own, whether it's through something like W3 Schools or whether it's something like Udemy, where you could go in and take courses over time, 6-8 weeks. Or whether it's doing it with one of our larger programs that we have at WebAge here, self-study or guided learning through instruction, whichever methodology you or your organization can use, it's important to use those methodologies to achieve proper instruction for the folks that are going to take on those roles. Whether we're upskilling somebody that's doing data analytics into the data science role, or upskilling somebody that's a data engineer into the data science role, or maybe not, right? It depends on the organization. Maybe we can hire folks in those specific areas. I'm not saying you need a master's degree, but we're certainly saying that you need a good understanding of modeling and the mathematics and science around that, including what exploratory data analysis is, how to form, hypothesis. It's not your grade school level stuff that we're talking here. It's adding on to that. So some kind of information around that. Then deployment and monitoring. So again, we're going to break these down. Scoping, I'm assuming everybody understands that we're told that we need to find this answer. So I've kind of left the scoping piece out, but data engineering, right? Collecting the data, establishing the baselines, cleaning the data, formatting it, labeling it. Those are all of the standard things that we often do. Looking at the data, preparing the data, getting it ready for use on some kind of resource, right? Because we move it from its original raw state to some new location. Could be an RDBMS, could be a data warehouse like an EDW, enterprise data warehouse, or some kind of NoSQL, Hadoop, Mongo, Cassandra, Spark today that we're moving that resource to. From the modeling point of view, we talked a little bit about training just a moment ago. That's kind of the first part of the job, right? Taking some percentage of the data, applying our machine learning algorithm against it, whether it's one that we're creating or whether we're buying it off the shelf, or maybe we're using, scikit-learn, whatever the case is, we are getting at some kind of model that we are going to use against our data set. And, for folks using Python and PySpark, it's pretty much coming from today, something like Anaconda and scikit-learn. There are others, as I said, available for this, but this is kind of a nice one that you can come in and very quickly look at, kind of the code behind here to be able to produce, the model that we might want, and then the visualization that we want to be able to show to the end users. However you do that, whether it's Amazon or Azure or Google, or whether it's locally on your own machine, that processed data is often problematic in some way. We haven't cleansed it properly. We haven't pulled out and replaced the missing values and things like that. So the data scientist still is often tasked with further cleansing, right? Further aggregation of the data, further reconciling of the data. That does not get lost here at this point. We still have to go through and do other things. So error analysis is going to be done. Error management is going to be done. And then finally, once we get the model ready, right, we need to track that model performance. That means monitoring it in some way. Lots of tools out there to do that. If you go back and look at Kelvin's site, you're going to find that he's listed some great tools there. It could be something as simple as using something like Prometheus to do that. It could be a lot more complex to do that. And then, of course, as we said, as the data changes, we will update those models. Deployment means packaging the model. I mentioned earlier, if we're doing something like this with edge devices or cloud devices, maybe we're exposing things via an API server, right, in the cloud. If it's on-prem, maybe we're just uploading our zip file or our pickle file, or if it's Java, our jar file, and we're making it available, right? We may be using, as we said, Docker containers. It's quite common today to create the container environment, as we said, because this allows us to scale the environment as needed. And in particular, all of our cloud providers, but on-prem as well, with VMs from packages like using VMware for scaling could be done as well. We could use Terraform for that. To scale the resources and set them up. We have a lot of choices here, in other words. And of course, deployed on a serverless cloud platform, we've got folks that are using everything from AWS Lambda functions to other types of applications like SageMaker, which we saw already. We've got Azure, where we have Azure ML, and we've got Google. We mentioned let's say data proc, because that's the Hadoop version, but we also have data flow if we want to use streaming data through Spark. There's others as well. But some kind of operation that we're working on with the data. We may even have to deploy it to a mobile app and grab that information back from that ARM processor. From the analysis side, there's many tools that are used here. Remember, we're looking at answers. Model drifting is a big one. Model drifting over time, of course, is problematic, and that probably means that the model needs to be updated. The last one, this takes me back to a longer course I was teaching a few weeks ago, where we actually had a discussion about overfitting and underfitting data in a project that was presented by one of the folks in the classes, Jordan. So we really have to understand the data and how we can tweak it. Remember, if you're overfitting or underfitting something, what you're probably doing is getting something that looks like this, thinking in the form of linear regression. You might get something that looks like that, where the model is starting to bend down. The straight line model is not what unfortunately what we're achieving. Our goal would be to essentially have a straight line model shown here for regression, more straight, as opposed to something that is overfitted or underfitted. In the case of working with skewing of data, which happens quite often, right? The data may be skewed to the right or to the left. Let's say we originally have something that looks like this, and then the data gets skewed this way, or the data may get skewed in the other way, which is right skewed, right? Something like this. Our intention all along was to ensure that the data was kind of here, but because we've used maybe a median or mean or mode, or we've done some other kinds of cleansing on the data, we're getting this skewed environment. I said earlier that that's okay to have something that is in a skewed environment, as long as the data scientist reports to us ahead of time that that's exactly what happened. There's lots of code libraries out there, as I mentioned. So scikit-learn and others, you can grab a plethora of them and start going today very quickly to implement your application of your machine learning. Finally, monitoring, what's the load, what's the usage, how much storage, what's the health of the model itself that was deployed. We can also get other insights like the performance and accuracy and loss, the bias, which again comes into skewed and other types of bias that can be presented. And of course, the data drift, because over time the data is changing, the model is not as accurate as it was before. Remember, we're always looking at real world or non-real world scenarios, but most times real world scenarios are what we're tracking, because we're dealing with business and we're dealing with business insights. So it's always based on something that is real data. If we were doing stuff on Mars, that might be different, right? We might want to come up with some projected data or data that we are creating on our own. Here, the idea is to deploy the model, the system, of course, monitoring it. And I mentioned Prometheus and other things. There's lots of ways of collecting model logging, user access log, prediction logs, and things like that. Remember, we're trying to maintain the model. Graylog is a great one for doing this. Elastic Stack, which is a combination of 3 pieces, typically, Elasticsearch, some kind of Kibana or some other type of tool, and maybe Logstash. And then, of course, FluentD. FluentD is going to be more appropriate for doing something where we have Docker containers and things like that, because this will run as an agent. And it can monitor the individual applications running within the Docker containers. Again, there's lots of choices here, so I'm not saying that they all fit necessarily to what you might be doing, but these are important considerations as you're going through. Here's a great little chart around that and the things that need to be done. So notice on the build side, we start off with the data collection, the feature engineering, right? Building the model, validation, and testing. On the control side, we're doing the versioning, as we said earlier. We're auditing the system, and we're creating templates like you saw in SageMaker that I can work from again and again and again, like my k-means template here that I can go in and clone, right? Remember, we saw this earlier. That gives me a great starting point. There's other types of templates that we can use as well. So depending on the world that we're working in, again, this is something that we need to think about. As far as building it, then we probably need to be monitoring it continuously. The feedback loops, of course, are going to let us know how it's working. The metrics and ROI, return on investment will let us know kind of what's going on. And then over time, right, we redeploy, we automate that process. Those are keywords that we want to take away from kind of this idea of training today. Auto ML is where we're headed with everything today, and there's lots of features around that that we're going to need to take advantage of in the very near future, simply because the amount of data that we're dealing with and the amount of systems out there, are becoming more and more featured full or feature rich. I want to take you over to Neptune. This is one of the AI tools out there because I really didn't talk about AI yet, and I do want to do that before we finish out kind of the day here. Oh, I didn't put my towards data science in. So this is the Neptune one. Again, when it comes to ML workflows and so on, the lineage of that, Neptune allows you to do that. Unfortunately, I didn't have a chance to download this ahead of time, but you can see we've got some data samples here. We then go through and create our Python application. Then we start to train the model. We get the model trained. We looked at the projections of what it's telling us. This is about sales of different types of clothes, and hopefully it's going to give us an opportunity to understand that better. There's lots of opportunities out there for using tools like Neptune and others. So again, Neptune just happens to be one of them. MLflow is a tool that we use in my world. Apache Airflow is also another tool that's quite common in this area. This is actually from a Canadian company, MLflow, out of Toronto. Really like it. Again, it allows me to keep that management of my, machine learning lifecycle, checking things in, maintaining it. Again, on-prem here as opposed to cloud-based. We already saw the cloud-based system, so I often get asked about these ones. Comet's another one that you'll see out there for tracking, comparing, explaining, optimizing your models. So again, want to give you resources that you can go and look up on your own and see. So that's what I'm always about here when we're doing training. And I hope you find that is useful for you. If you want to play or experiment with Neptune, they actually have an online tool that you can play with, much like Databricks has tools for working with Spark. You can do the same thing here. And of course, metadata, charting, monitoring, right? Source code, artifacts, which of course are changes over time to our ML model. All of those are part of the system that's available there. So what are some of the benefits? Better management, right, of the data sets, debugging, monitoring, updating, use tracking, reusability, reusability, reusability. That's really what we're talking about here. That's the big benefit of MLOps. Where's this headed? Well, we break it down into a couple of areas. Productivity, self-service environments are becoming more and more prevalent for our data engineers and data scientists. We just saw one, Neptune. We saw earlier ones with SageMaker and so on in the cloud-based environments. Repeatability, so automating that process. We can do that through scripting. Maybe we create something with a CDK toolkit that moves data from our on-prem system to the cloud in TypeScript or Python or some other language. Automating that process for the data engineer will speed up the ability of the data engineer to then work with the feature sets, create all of those pieces that are so important to us in understanding. Deployability, right? ML deployment operations, that's our ML ops, just not throwing it over the wall. We want to have it checked out on the dev side before we apply it to the ops side. So CI/CD best practices here, quality, consistency of the data. Auditability, right? Versioning, we talked about that earlier, but also looking at who's using the model and how they're using it over time is important. And of course, the quality of that, tracking the changes, knowing the biases, as I said, very, very important going forward. Where's this all headed? Well, there's more and more organizations today that are providing enterprise customers with solutions. And there is a new marketplace already out there for this kind of organization. And we've seen some of that. I mentioned to you in SageMaker that we can go out to the AWS marketplace and we can get model packages, we can get algorithms. There's all kinds of things now available. This is not the only organization that's doing that. We could also go to Databricks. We could go to Azure. We could go to Google. We could go to somebody within our own organization as well that probably has packages that are available. So now we can make our own packages available within the organization. All right. I hope that that gave you some insight into what MLOps is today, whether we're working on-prem with pandas or R, and then translating that to movement to the cloud. That really was the intention of the presentation. As I promised, I will now upload my marked up notes here so that you have them. That's these. So please feel free to download that. I hope you were able to gather some information. I highly recommend that you go off and look at Kelvin's information here. Very excellent source for all kinds of things that we discussed here in our very short time frame of an hour. And I want to thank you all for coming out for the training. I'll open the floor, see if there's any questions. Welcome back, Corey. I just realized you said that you had come to this session as well. So welcome back, Amanda and Andrew. Nice to see you again. Any questions around the materials? As I always do, I'll put my email here. So, please feel free to reach out if you have additional questions around the subject matter. Always great to have, you reach out. Please feel free to do so. All right, that leaves us with about 30 seconds here. So again, thank you. If you want to know more about machine learning and machine learning ops, of course, WebAge has sites as well that you can go and look at today for that information, or join us for one of the sessions that we have available on a regular basis. Thanks, everybody. Nice to meet you. Thanks for being here. And again,